In case number 2, we are going to subtract, that is equation number from equation number 2, we are going to subtract equation number 3. But equation number 2 is of g is equals to root of ab, and equation number 3 is of h is equals to 2ab by a plus b. So I am going to subtract g minus h on the left hand side. So here g minus h equals to, but g, the geometric progression, the geometric mean, so geometric mean is given by means of, geometric mean of two numbers is given by means of, say root of ab minus h, the harmonic mean is given by means of 2ab overall divided by a plus b. Then the next logical step will be of, that implies root of ab divided by 1 minus 2ab divided by a plus b. Then now next logical step will be of, so LCM of 1 and a plus b will be of the bracket, that is a plus b. Numerator root of ab is written as it is. Then now when a plus b, that is LCM divided by 1, that is a plus b overall divided by 1 gives us the same a plus b. So into a plus b, or 1 a plus b times is of a plus b, minus numerator must be written as it is, must be multiplied with a plus b overall divided by a plus b, both will be gets cancelled once, then now here it will be 1, or in other words a plus b ones is of a plus b. Then now the next logical step will be of, that implies root of ab into a plus b minus 2ab ones is of 2ab overall divided by a plus b. That implies root ab into a plus b minus 2 into, so here ab, so here I wrote that root of a whole square is equals to only a, because square and the square root gets cancels, only a is left over. At the same time, so here under root, if it is of ab whole square is equals to, when square and root gets cancels, only ab is left over, or in other words ab can also be written as root of ab whole square. So based upon this principle, we can write this ab as root of ab whole square, root of ab whole square. So we can check up, square and the root gets cancels, only ab is left over. So overall divided by just a plus b. Then the next logical step will be of, so among, so this is of first term minus this is of second term, root ab's are of 2 here, because the exponent is 2. Here root abc is of only 1. So I am going to take one root ab as common. Then if root ab is taken out as common, just a plus b is left over within the square brackets, minus, there are of 2 root ab's, among 2 root ab's, 1 root ab is taken out. Then now 2 into, this 2 is written as it is, out of 2 root ab's, 1 root ab is taken out as common, then now 1 more root ab is left over within the bracket. So overall divided by a plus b. Then now, as per this condition, that a can be written as root a whole square, this a can be written as root of a square, and b can be written as root b whole square, and this can be splitted as, so here root of ab can be splitted as root a into root b. Then now, then the next logical step will be of root ab, that implies root ab square bracket. So here a can be written as root a whole square, and the next term b is there, so b can be written as root b whole square minus 2 into root ab can be written as root a into root b whole divided by a plus b. Then now when we assume, say root a as a, so here at a equals to, capital A equals to root a and b is equals to root b, so when we assume in this manner root b as b, then root a will be again a, then root b will be of b. Now it is in the form of a square plus b square minus 2ab. So here we know a square plus b square minus 2ab can be written as a minus b whole square based upon this special product. So here the next logical step will be of, that implies root ab into, since it is in the form of a square plus b square minus 2ab, we have to write it as a minus b whole square, but a is of root a minus b is of root b whole square overall divided by a plus b. Whereas, so now we can write it as, so left hand side quantity is of, so here as per the case number 2, so left hand side is of g minus h. Then now, so here g minus h is equals to root of ab into root a minus root b whole square overall divided by a plus b. But here in this right hand side, root a minus root b whole square is a perfect square. Perfect square multiplied with root ab is also gives us some perfect square. So therefore, so it had right hand side quantity has one perfect square. Then if since there is a perfect square on the right hand side, then g minus h value will be always greater than or at least equal to 0. So yeah, since root a minus root b whole square is a perfect square, hence g minus h value will be greater than or at least equal to 0. So here let us write it as the equation number 4. So from equations, that is 3 and as well as 4, so equation 3 is of third equation from case 1. So third equation from case number 1, the third equation is of a minus g greater than or equals to 0, and from case number 2, the fourth equation is of g minus h greater than or equal to 0, which is the fourth equation. So here a minus g greater than or equals to 0 is the equation number 3, then g minus h greater than or equals to 0 is the equation number 4. So here from these two equations, that is a minus g greater than or equals to 0, which is the equation number 3, we can write it as, that implies a when minus g is transposed over to the right hand side, so it becomes positive, that is minus g on the other hand, so here plus g. So here in other words, by adding g on both sides, so we can get it as, so here a greater than or equals to g. So here let us suppose this as equation 5. Then now at the same time, g minus h is greater than or equals to 0 is the equation number 4. From this we can write it as, so here that implies g greater than or equals to, when minus h is on the left hand side, when we add h on either side, that is minus h plus h will be gets cancelled, there will be of plus h. So here plus h on the other hand. So this will be of the equation number 6. So from 5 and 6 equations, that is a greater than or equal to g is of the fifth equation, and the sixth equation is of g greater than or equals to h is the equation number 6. So from these two equations we can write it as a is greater than or equals to g, therefore a is greater than or equals to g, but this g is again greater than or equals to h. So here hence a is greater than or equal to g greater than or equal to h.